Hello students, welcome to Husky Math. I am Siddhant Rai. From here we will be doing differentiation, the first principle. See, the first principle means if I find the derivative of a function using the definition of differentiation, then that is called the first principle. Okay, so here are some theorems which we need to do. It's not necessary, this is not the exercise actually. These are the theorems which you can see, or you can skip to the exercise part, but it's good if you watch all this video. Okay, so in theorem 1 we have from the first principle, so that d dx of x to the power n equals to nx to the power n minus 1, where n is a fixed number, integer or rational. Now as you can see here, our function is x to the power n, so I will assume x to the power n as y. So let y equals to x to the power n. Okay, and let this be equation 1. Now let us assume that there is an increment of delta x along x-axis and delta y along y-axis. So therefore y plus delta y will be equals to x plus delta x whole to the power n, and let this be equation 2. Whenever there is an increment of delta x, there is an increment of delta y. So in place of y I have written y plus delta y, so here it will be x plus delta x in place of x. Now let us subtract these two equations. Okay, so let me subtract equation 2 minus equation 1. Then on the left hand side I will be subtracting this minus this. Okay, so it will be y plus delta y minus y equals to, and on the right hand side x plus delta x whole to the power n minus x to the power n. Here minus y plus y gets 0, so we will have delta y equals to x plus delta x whole to the power n minus x to the power n. Now let me divide both sides by delta x. It will be, so what I'm doing, I'm just dividing left hand side and right hand side by delta x. Now let us put the limit delta x tends to 0 on both sides, so it will be limit delta x tends to 0 delta y over delta x equals to limit delta x tends to 0 x plus delta x, sorry I have written 2 here, it's actually n minus x to the power n whole divided by, now here in denominator I will add x and subtract x. Okay, now on the left hand side, as you can see, limit delta x tends to 0 delta y over delta x, this is dy by dx, so it will be dy by dx equals to, as delta x tends to 0, if I add x on both sides, then it will be x plus delta x tends to, x plus 0 is x. Okay, as delta x tends to 0, x plus delta x tends to x, so I will use that here. Limit x plus delta x tends to x, x plus delta x whole to the power n minus x to the power n by x plus delta x minus x. Now in the previous chapter limit we had one formula, that is if limit x tends to a, x to the power n minus a to the power n over x minus a equals to n a to the power n minus 1. In previous chapter we had this formula. Okay, now if I match this portion with this, then I can use it here. In place of x I have x plus delta x, and in place of a we have x here. So let us use that formula, then we will have dy over dx equals to our n, a means x, x to the power n minus 1, and hence see what was our y? Our y was x to the power n, because that function was y. So here I can write d dx of x to the power n equals to n x to the power n minus 1, and that is the proof of this theorem.